Hi, everybody. So thank you for joining us today. On behalf of ODU, Dominion University, we welcome you to REYES, which is the remote experience for young engineers and scientists. My name is Orlando Ayala, and I'm an associate professor in the Genetic Technology Department here at ODU. Today, I will be serving as your moderator for this science session titled Green Infrastructure and Climate Resilience. With the current problem of sea level rise, this is a topic that I know all of you were going to find interesting. And by the way, my dear friend, the speaker today, Professor Considine, is very knowledgeable on the subject. Professor Considine is an assistant dean of outreach and diversity in our college, the Batten College of Engineering and Technology. She's, like I said before, she's my colleague. I can call her my friend as well. She's in the same department as me, and she's also an associate professor as myself. She's awesome, awesome to work with. It's always nice to be working with her. She received her bachelor's degree in civil engineering from Virginia Tech. Our enemies, but for that we're fine. um, the good enemies in a good sense. In a good sense, we are good rivals. Um, and she got her master's degree in civil engineering from the University of California in Berkeley. Anyway, this presentation will take about 30 minutes, and after that, we'll switch to the question from the audience. Feel free to send me your questions while she's talking. I'll hold on to your questions to the end, and Professor Considine will answer as many questions as possible. So I know we're going to get bombarded by questions, but if we didn't get to answer all your questions, I'm going to send the question to Professor Considine so she can answer and make them available through our website. In any case, without further ado, here's my dear colleague and friend, Professor Carol Considine.
Thank you, Orlando, for that really warm welcome. So I'm happy to be here with all of you today. I'm a civil engineer, as Orlando said, and I became interested in understanding climate change about 10 years ago. So about 10 years ago, I became a accredited leadership in energy and environmental design professional. And that is a certification that's issued by the United States Green Building Council on how to design and build green buildings. And as I went through the studies to become a lead AP, I became really interested in climate change. I really didn't know that much about climate change. And so I started learning more about climate change. And about the same time, Old Dominion University started their Sea Level Rise initiative for us to work with local communities to help become more resilient and adapt to sea level rise as we move into our future. So I really was excited to learn about climate change, and it really motivated me to think about how I can participate in mitigating climate change as well as helping my community adapt. So last year I bit the bullet and I bought an electric car, and I love it. It's like the best thing ever, and I recommend it if you're thinking about getting a car, buy an electric one. But I've also then been focusing on sea level rise in Hampton Roads and what are some strategies that we can adopt to make our lives easier here. And green infrastructure is one of the strategies that actually can help us become climate resilient and help us with the flooding impacts that we have here in coastal Virginia. So if we're going to talk about climate change, I think it's really good for us to go ahead and take a look at what are some of the historical indicators of climate change. So this slide is from the National Climate Assessment from 2018. You can access it online really easily by just Googling it. It's an excellent document. And if you want to learn more about climate change in the US, I recommend that you go to this website. So what we have here are the historical changes that we're seeing related to climate change. And the first of those is temperature. We've actually had a 1.8 degree Fahrenheit increase in temperature since the beginning of the 20th century. And so we know that temperatures are increasing. We also know that heat waves in the United States are increasing. So what we've seen is that the season length of heat waves in the US cities has increased to over 40 days since the 1960s. We're also seeing an increase in precipitation related to climate change. So the city of Virginia Beach here has actually done a study, and they have decided that based on current standards for precipitation, there needs to be a 20% increase to precipitation standards from now until 2060, because we know that we have seen this increase. The National Climate Assessment puts this in terms of annual days with precipitation greater than 3 inches, and they're saying that these events have increased since in the past century. In the Western United States, we've seen a decrease in snowpack between 1955 and 2016. In terms of drought, there's no detectable change in drought conditions when we look at using the Palmer Drought Severity Index, which is an index that's typically used to measure drought. Over here, when we look at Arctic sea ice, we know that we've had a decrease in the extent of Arctic sea ice, and that's 11 to 16% decrease in Arctic sea ice per decade since the early 1980s. And then sea level rise. Nationally, we've had on average a 9-inch increase in sea level rise since the beginning of the 20th century. But sea level rise in Hampton Roads, so relative sea level rise, taking into consideration all conditions in Hampton Roads, we've actually seen a 1.5-inch increase in sea level rise since the beginning of the 20th century here in Hampton Roads. When we think about our marine species distribution, we are seeing shellfish and fish and other marine species move north and also move into deeper water, deeper, cooler waters since the early 1980s. We are seeing ocean acidification increase, and this is based on the amount of carbon dioxide that is being absorbed by the oceans. The oceans currently absorb 25% of the carbon dioxide that is emitted into the atmosphere based on human activities. Our growing season has lengthened, which means that our last frost in the spring is occurring earlier, and our first frost in the fall is occurring later. So we're seeing this larger growing season. Wildfires have increased, and this is especially being seen in California and Alaska. And then our heating and cooling days. We're seeing a decrease in the number of heating degree days. So those are the degree days less than 65 degrees Fahrenheit. And we're seeing an increase in our cooling degree days where we have days over 65 degrees Fahrenheit. So these are the historical indicators of climate change. So then I want to focus on my region, which is the southeast region of the United States. And if I looked at what are the expected climate impacts that we're going to have, we know that temperatures are going to increase. So if we look at this diagram in the upper right-hand corner, what we see is this is based on the representative concentration pathway of 4.5, which really is kind of a stabilization scenario with approximately 650 parts per million of CO2 in the atmosphere. And so what we can see here is that on the left side here, this goes to mid-century, about 1960, and we can see that we're having maybe 20 nights where the temperature is greater than 75 degrees here in where I live in Hampton Roads. And then we can see over here, and this is at the end of the century, that we're closer to probably 30 days or 30 nights where our temperature is greater than 75 degrees. But we can really see the impacts down here in the south, right? Louisiana and Florida really have a lot larger increase in the number of nights with that minimum temperature greater than 75 degrees. I've already talked about the rainfall intensity that we expect to see here in the Hampton Roads region, and this graph down here shows the days exceeding a 24-hour 2-year rainfall in Norfolk. And so here we are in 2020, we see that here, and then if we go to 2060, which is that 40 years, we can definitely see that there is an increase in the number of days since 1950 in which we exceed that 24-hour 2-year rainfall standard in Norfolk. I want to focus just on sea level rise for a little bit. This graph here actually shows relative sea level rise for Norfolk, Virginia. So it takes into consideration our geology and our location. And so our sea level rise here in Hampton Roads is larger or greater than the global sea level rise for 2 specific reasons. One, our land is subsiding. So our land is actually is falling, essentially, at a very slow rate, but it is falling. And then along the eastern seaboard, we have the Gulf Stream. And what's happening with the Gulf Stream that runs from the tip of Florida to Newfoundland is that the velocity of the Gulf Stream is actually slowing. So as the velocity of the Gulf Stream is slowing, it actually increases sea level rise along our landmass. So Tal Ezer is a professor in our oceanography department here, and I asked him to explain that phenomenon to me, and he said that I could compare it to kind of a cup of coffee and pouring cream into the coffee. And if you stir your coffee, right, the faster you stir, the larger the distance is between the coffee at the center of the cup and the edge of the cup. And if you slow your stirring, then that difference in elevation decreases. So that's the phenomenon that we're seeing happen here along the eastern seaboard, especially in our Norfolk area. So the Commonwealth of Virginia actually has adopted the NOAA Intermediate High Curve as the scenario that we use for sea level rise planning. So this graph here actually shows three different organizations' sea level rise scenario. VIMS is the Virginia Institute of Marine Science. They're located near Williamsburg, Virginia here, either in York, Virginia, I believe. And they have their projections, but you can see their projections only go out to 2050. We have the National Oceanic and Atmospheric Administration scenarios, and those are the purple ones in the middle here. And then we also have the United States Army Corps of Engineers scenarios, which are here. So as I indicated to you, the Commonwealth of Virginia has actually adopted the intermediate high curve, which is this dashed purple line. So we can see that this line is right here. So if I come back to 2020, here's this line, and if I extend out to 2100, we are expecting to have a sea level rise greater than 6 feet in the Hampton Roads region. And that's a lot of water for a very low-lying area. So in Hampton Roads, most of our region has an elevation of 10 feet or less. And so this has a huge impact upon our region. This is an example or a diagram also from the National Climate Assessment that shows the increase in high tide flooding. So this isn't for Hampton Roads. This is for Fort Pulaski near Savannah, Georgia. But I think it demonstrates the same thing. So we can see here that this black is historical observation of high tide flooding, and the gray is an extension of the historical, just taking out a trend line. But what we know about sea level rise is actually accelerating. It's not accelerating at it's not increasing at a constant rate. It's actually accelerating in sea level rise. So what we see here is if we look at using an intermediate low scenario, here we are in 2020. By 2040, we can expect to have maybe 60 high tide flooding days per year. But when we get to 2100, we can expect to see about 250 high tide flooding days per year. And I indicated to you that we were using the intermediate high scenario here in Hampton Roads, and the light blue color here is actually using an intermediate sea level rise. So we're really going to see an increase in this high tide flooding, and we really need to come up with some solutions that can keep our economy strong and allow us to live in these vibrant coastal areas, because 40% of the population in the United States actually lives along the coastlines. So again, this isn't exactly for the Hampton Roads region, but we are experiencing the same situation where we are seeing high tide flooding in our region, and it is increasing. So one of the things that I really want to focus on for just a few minutes here is our stormwater. So stormwater runoff actually causes major pollution in urban areas. When the rain falls on our roofs and our streets and parking lots, it actually can't soak into the ground because there's so many impermeable surfaces. So the stormwater drains down into our gutters, into our storm sewers and other engineered collection system, and it's discharged into nearby water bodies. So the stormwater carries with it trash, heavy metal, contaminants, and other pollutants from the urban landscape. And higher flows from heavy rains, which we said we expect to see heavier rains, also cause erosion and flooding in urban streams, damaging habitat, property, and infrastructure. When we compare that to a rural area, the rain falls into natural undeveloped areas. The water is absorbed and filtered by the soil and plants. The stormwater runoff is cleaner, it's less of a problem. And so green infrastructure actually uses vegetation, soils, and other elements to practice and restore some of these natural processes required to manage water and create healthier urban environments. But we can also look at it at the city or county scale as a way to weave these practices into our environment and then mitigate some of the runoff that we see from these storms that are occurring. So I wanted to show you this picture because these are actually two stormwater pipes that release stormwater into local streams. And so what's really interesting here is, I mean, half of this pipe is underwater here, and actually probably half or even more of the pipe is underwater here. So one of the problems that we're seeing in Hampton Roads is as sea level rise, we have this infrastructure that was built 20, 40, 60, 80 years ago and didn't take sea level rise into account. So as sea levels rise, the seawater or the river water backs up into our gray infrastructure stormwater systems and actually decreases the capacity of those systems. So not only are we having more rain, we have less capacity for the rain in our existing systems. And so this is where we can really look for alternate solutions that can help us mitigate those impacts. And green infrastructure is one of those solutions that can help us mitigate it. So these are some examples of flooding here in Hampton Roads. This is actually, this first picture here, this is tidal flooding. So this is an area in Norfolk that's open to the Elizabeth River. And so when there's a high tide event, the water comes into this area and floods the streets here. But many of these pictures are actually from the city of Virginia Beach. And these are flooded roads that are not necessarily near any body of water, but the storm water that falls is so intense and there's so much of it that it overwhelms these systems and it doesn't have anywhere to drain from. So I personally have had situations where I'm leaving work, we have a heavy rainfall, and I'm weaving through different streets trying to find a dry way to get home in Hampton Roads. So we really have to be proactive in trying to solve some of these problems. So the Environmental Protection Agency identifies green infrastructure as a set of stormwater best management practices that collect, infiltrate, and reuse stormwater where it falls or is created. And really, again, we're trying to mimic those natural hydrological systems that we've disrupted by putting in so much impervious pavement in urban areas. But when we think about science and we think about urban land design, they think about green infrastructure in a much broader context. And they like to think about green infrastructure as these areas, large open areas of green space, right, that are connected by corridors. And what this does is it allows for a habitat, but it also creates habitat corridors where the habitat can actually move through this corridor to the next open space. And this actually creates a greater biodiversity within your region, allowing animals and critters to move along the system. So this picture over here on the right actually shows that same type of structure, but in a city. So we have a river here, and we have a stream that feeds into that river. And along the stream, we have 4 or 5 large hub areas where there's a lot of natural systems and areas where habitat can thrive. And they're actually connected by these corridors of green trees, plants along the river so that these animals can move along these hubs. And so when we think about green infrastructure, we shouldn't think about individual pieces necessarily. We might think about how do all these individual pieces fit together to create this more diverse, welcoming environment for humans and animals. So I'm going to show you, I think, about 16 different green infrastructure techniques that we can use. And some of these are pretty simple, and you can actually implement them into your own house. So the first is this downspout disconnect. And so when the water lands on our roofs, it goes into our gutters and into our downspouts, what we want to do is release that water onto either soil or planting areas so that it can be infiltrated or absorbed. In some cities, the downspout is actually connected to the stormwater system, so the water just automatically enters into this hard pipe system and is released into our streams. So if that happens to be your situation in a city that you live in, you want to disconnect that and let that water enter into the system on your property. Another opportunity for us is to do rainwater harvesting. So rainwater harvesting actually collects the water, and it can be used later, or it can be released once a storm is over. And the water that's collected is non-potable water. So we can't use that water for drinking or washing dishes, but we can use that water for flushing toilets or watering our lawn or washing our cars. And so when we do that, it actually decreases the demand on our potable water system, which can actually help with the recharge of our aquifers and our natural systems. Rain gardens are actually really great features, and they're very simple. So they can be installed in almost any unpaved space. They're essentially bioretention cells. They're shallow vegetated basins that collect and absorb runoff from our rooftops, streets, and sidewalks. And they actually practice natural hydrology. They allow the water to infiltrate, and it also helps with evaporation of water, the water that doesn't infiltrate right away, and even transpiration of water through the plant materials. So rain gardens are actually great features. I'm going to show you, I'm not sure how well you're going to be able to see this, but I actually have like a model of a rain garden. And so this would be a rain garden here where, and I think you can kind of see it, where the water would enter the top, flow through the system, and then if it's too much water and it has to exit the system, it has a high berm at the bottom so that the water actually gets filtered as it runs through this gravel and rock and can exit the system. But the goal is really to retain that water in that system so that it can actually infiltrate into the ground. Planter boxes are another opportunity for urban rain gardens. They actually have vertical walls. And you can see in this picture, there's an opening to the street at both ends, and there's also an opening to the sidewalk here. So the water from the street and the sidewalk can enter into that planter box. And some of the planter boxes are actually open on the bottom, which allows the water to infiltrate. Some are closed on the bottom. So in that case, the water would collect there, have an opportunity to evaporate, and if there's too much water, then the excess water could enter into the storm drain system. Bioswales are vegetated, mulched channels that provide treatment and retention and movement of water from one place to another. The vegetated swales actually flow and infiltrate the water, and they're linear features, so they're really well suited for along roadways. And then over here we have wetlands. And here in Hampton Roads, we're actually starting to build more wetlands in areas where they've been eliminated, or they've been haven't done well, because what we know about wetlands is that they are essential wildlife habitat. They're actually massive water filters, and they're natural basins to hold water and attenuate wave action. They actually act like sponges and absorb precipitation and runoff, and slowly release it into the ground and their outlet streams. This picture up here is permeable pavement. So permeable pavement actually allows water to infiltrate, treat, and it store water. And you can either find pervious concrete pavement or pervious asphalt pavement. They also have what they call permeable interlocking pavement, where you actually can put these pavements together. And this practice is really good for areas that are low traffic, maybe parking lots, and they're best when they're combined with other features. So green streets and alleys are a way to combine multiple features, right? So you can see as the road bumps out here, there may be parking in this area. So you might want to do permeable pavement in the area of parking next to the curb. And then we can see that we've got lots of planting areas here, whether they're box planters or whether they're bioswales, right? It's an opportunity for water to be stored, infiltrate, and evapotranspire. But another interesting thing, and this picture doesn't have trees in that area, but you could put trees in these areas also. But another really interesting thing is that they've done studies that have shown that green streets and alleys actually slow traffic. So people drive slower in areas where they see green plantings than they do in areas that don't have any plantings at all. So it can also be used to kind of help with traffic management. Green parking is using, again, multiple techniques. You can use permeable pavement for the parking area, but you don't have those curbs that keep the water in the parking area, right? You have low curbs that allow the water to leave the parking area and move into areas where there are bioswales and opportunities for infiltration and storage of water. Green roofs are an excellent best management practice. They include growing media and vegetation, and they enable rain to infiltrate there, and they evapotranspire the stored water. They're particularly cost-effective in dense urban areas. And I don't know if you've been in a city where you could see a green roof, or you've been in a building and could look down on a green roof. We as humans love our connection to nature. So having that connection, seeing that can actually make us feel better. And some green roofs are in areas where you can actually walk out and enjoy being next to those green roofs. Urban tree canopy is really important. And this is a place where all of us can participate by planting trees. Trees reduce and slow stormwater by intercepting it on their leaves and their branches. And most cities are trying to increase their tree canopy. The tree canopy also provides shade. It actually helps with heat island effect. And one tree can take up to 100 gallons of water a day. So they really absorb a lot of water out of the environment, so they can really help us with some of our impacts from flooding. And then the last item to talk about is considering using large open spaces as a place to infiltrate water and store water in an urban environment. And so when we think about urban stormwater, we can really help with that by protecting our open spaces or creating more open spaces that provide us with an opportunity for that storage and treatment of water. But another thing about that open space is it provides opportunities for residents and citizens to actually get some physical exercise and gives them that opportunity to connect with nature. So we've talked about all the different types of green infrastructure, and I want to close by just talking about how green infrastructure is related to urban resilience. So we have talked about green infrastructure and about the flood risk, and green infrastructure really helps us by managing local flooding. And again, it's not a it's a solution that will take the first 1 or 2 inches of rain and allow us to manage it on properties before we start seeing that flooding into the streets. But in order for that to happen, it has to be a widespread practices of green infrastructure. But it really can reduce the quantity of water that enters the system, but it also reduces the increases the quality of the water that enters the system. So we have kind of less polluted water entering the system when we use green infrastructure techniques. It also helps us build resilience to drought. All of these techniques of green infrastructure either decrease our demand on our potable water systems and our aquifers or our streams, or they help us infiltrate water into our aquifers, or provide water in the case of a cistern that we can use instead of using potable water. It also, green infrastructure helps us reduce heat island effect. So when we talk about heat island effect, what we can see is an increase of temperature of 1 to 5 degrees in urban areas as compared to rural areas that are adjacent. And a lot related to all of those hard surfaces absorbing the heat from the sun. And then what happens at night is that it releases that heat, right? So we have this constant buildup of heat and releasing of heat in the cities. So by planting trees, providing shade, we can reduce that urban heat buildup, which can really help us with our energy costs for air conditioning. It helps with air pollution, and it can reduce some of the heat-related illnesses and mortality that we see in our urban cities. And then green infrastructure can help us lower building energy demand. So shade from trees on houses can actually reduce our cooling costs in the summer. So I recently had to take down a huge oak tree that shaded my we call it a room over the garage, and it really shaded that room. And once we took that tree down, that room is much hotter than it used to be, and the air conditioning system in my house doesn't keep up with that. In addition to that, when we talked about green roofs, one of the things that green roofs do is they actually insulate a building. So instead of it just being a roof with insulation that does do some insulation, green roofs actually increase the amount of insulation. So what that means is that in the summer, you have less heat absorbed by the building through the roof, and in the winter, you have less heat released through the roof, and so that can really help lower our building energy demands. In terms of reducing energy needs, we just talked about how heating and cooling and green roofs can reduce energy demands, but also managing the storm water can help us reduce energy needed to transport water. So when we think about using water, here in Hampton Roads, if everything is so flat that we actually do have to pump water to people, potable water to people's houses for them to use it. So if we can use cistern water or stored water, then that reduces that demand. But also when our storm water enters the system here in Hampton Roads, our water is actually dumped into local streams and rivers through stormwater piping systems. But in some inner cities, they actually combine the stormwater with sanitary water, and all of that water goes to a water treatment plant. So if we can actually keep stormwater from entering those types of systems, we're actually reducing the energy needed to transport it to the treatment plant, and also reducing the cost and energy needed to treat that water at those plants. And then lastly, and this is extremely important here in Hampton Roads, green infrastructure improves coastal resiliency. So we know that sea level rise and storm surge cause erosion and flooding of sensitive coastal areas and destroy natural habitat. So living shorelines can reduce erosions and flooding, and in addition to that, the wetlands picture that I showed you before can reduce actually wave height. So when a storm surge comes in, it has a kind of a front wave height to it, and wetlands can actually reduce that storm surge, that wave height, and that actually reduces property damage. So green infrastructure has so many benefits to all regions in the United States. And what's really interesting is, like, we're not just seeing green infrastructure being implemented in coastal communities. Communities like Washington, D.C., Cleveland, Ohio, Minneapolis, Minnesota are all adopting these practices to improve their climate resiliency. So it's not just coastal resiliency, it's climate resiliency, and we're seeing it throughout the United States. And so in closing, I'm going to ask you all to do your part and plant some trees, put in a rain garden, collect that water on your property, and give it a chance to infiltrate rather than entering into our stormwater systems. So I'm available for questions. Raphael? I'm not sorry, Rafael, Orlando.
That's okay. We're from the same country, so very good. Rafael is our associate dean for undergrad. He's a very good friend as well. Same from the same country. And anyway, Carol works with him every day, so that's why she got confused. But yes, we have a couple of questions from the participants. We have the first question I have from Luis Angel Vergara Ortiz from Hidalgo, Mexico. What do you think about your expert opinion that humanity has about 30 years to stop this problem? And he thanks you for the presentation.
So I agree with you, but I don't know that we have 30 years. I think we really need to take a much more aggressive stance on climate change, take personal action, get our governments to take action to mitigate climate change impacts. And as a citizen of the United States, I'm disappointed with the progress that the United States is making, and I'm disappointed that we pulled out of the Paris Agreement. But one thing that gives me hope in the United States is that individual cities themselves have decided that they're going to cut their carbon emissions and that they're going to implement some of these practices. And the other thing that we're seeing as climate is changing is a realization that we may not be able to build hard infrastructure to save ourselves from this problem, that we have to look at these alternative natural solutions like green infrastructure that can really help us have a more livable society as climate is changing. That's a great question. Thank you so much.
Great. Let me see. So I have another question here, and the question is from Thais Diaz Soto from Puerto Rico. Do rain gardens attract mosquitoes? And if they do, can we prevent it in some way?
So standing water, I'm not an expert on mosquitoes, but my understanding is really standing water that attracts mosquitoes, right? They lay the eggs and the larvae, and then they go through that process. So what we need to do is not have standing water. So if we have rain gardens, having an overflow system where if there is standing water that it is eventually drained out of the system is really important. And here in Hampton Roads, the city of Norfolk has real flooding problems, and they actually considered having blue roofs, right? Where instead of a green roof where they would put plants on there, that they would have blue roofs and they would store stormwater on them. But they actually moved away from that idea because of the concern that you brought up with mosquitoes. And I think the Zika virus is a virus that is a mosquito-borne virus, especially in Central and South America. And I don't know if you have the Zika virus in Puerto Rico, but that was one of the concerns, is that as temperatures increase, we're going to have these viruses that are mosquito-borne. And you're right, we need to control mosquitoes. So if we're going to use green infrastructure, we need to consider that there's alternate ways to drain the water if it doesn't naturally infiltrate in a short period of time.
Thank you. So the next question I have is, are corridors always useful in a place? And this is from Kiara Rivera from Coamo, Puerto Rico. In a place as Venice, where the water takes almost the whole city, how can the corridors be used in a way that helps their annual flooding?
So it's kind of interesting, but even in New Orleans, they adopted some of this blue-green infrastructure projects, right? And they actually, for their blue infrastructure, they wanted to make sure that the water was connected and flowing through the city. And I think that was also related to concerns about mosquitoes and making sure that they had moving water. I'm not really that familiar with Venice to be able to address that question in terms of corridors and water there. I know that Venice has serious problems with flooding, and I know that I don't know how green infrastructure might be used in Venice specifically to help with that problem. So I don't have that knowledge, but I'll do a little research and see if I can add it to the questions answered after we get off the program today.
Cool. Another question from Catherine Shee from here, from Virginia Beach. How can we balance a space for natural environments and a space for population growth and urban development?
So that's a great question also. And actually, if you look at sustainable building practices, especially the USGBC LEED rating system, what they propose is that we build in a compact footprint, right? So we decrease the amount of space that we're using to build the building, and that we build up. So we make it a smaller space instead of, so maybe 1,000 square feet instead of 4,000 square feet. And then if we need more space, we put 3 or 4 stories on the building rather than 1 story. So we really need to think about how we develop a property. So if we look at a site, we want to make sure that we have a certain percentage of open area, that we can have water infiltration and natural features. We want to make sure that we consider the environment around us. So many sustainable building practices will not allow you to build within 100 feet of a river or a lake or the ocean, because they want you to provide a buffer between construction and those spaces so that our pollutants don't as easily enter the system. So we want to build with a tighter footprint, up higher, providing open space and natural areas as we build. And it's difficult to change how we think about building when we've built the same way for so long. But it's not just thinking about how to build differently. One of the problems that we have in the United States is that all of our building codes rely on historical data, looking in the past and what was the climate in the past. And as we know, with climate change, the conditions are going to be much different. So buildings that we're building now on codes that are based on historical climate from 20 years ago are not going to meet the requirements that we need for buildings in 40 years in terms of increase in heat, increase of heavy rainfall. So it is interesting that we really need to kind of rethink how we're building and what we're building. And especially here in the Hampton Roads region, we need to think about these flooding impacts, right? And new structures. One of the things that the Commonwealth of Virginia has looked at is, how much sea level rise do we expect? And then how do we build buildings that are more resilient to flooding impacts? And essentially it's about building up higher, right? Where the first floor elevation is high enough so that you aren't impacted by flooding.
Thank you. We have tons of questions, so hang in there. So the next one is, besides, this is from, I would assume it's Kiara Rivera because it's from Cuamo, Puerto Rico. Besides green infrastructure, what are some ways to solve the problem of climate change?
So that's really about mitigating our greenhouse gas emissions, right? And that's really about changing from oil-based energy sources to renewable energy sources. It's about thinking about the products that we manufacture and eliminating hazardous materials from that manufacturing and construction process. It's about looking for more energy efficiency in the buildings that we have, increasing insulation, using natural features from the environment in our buildings. So one of the things that the sustainable building practices from the USGBC try to have you incorporate is using natural light in buildings, right? Rather than including a bunch of electrical lights, but relying on the natural light that you get from the environment to light the inside of a building. Or instead of relying on heating and air conditioning to regulate the temperature where we live, looking at what are some of the natural winds that go across a property, and can you create an environment where you're using the natural winds and flow of winds that go across a property to cool a building in the summer rather than relying on air conditioning. So again, I really like the sustainable building practices standards that have come about, because they really do look holistically at buildings and try to steer people in directions of building new buildings or renovating buildings in a way that they have less of an impact on the environment. I did buy an electric car because it mitigates some of the greenhouse gas emissions. I mean, my electricity is still probably from a coal source possibly, but one of the things that's happening here in the Commonwealth of Virginia is that Dominion Energy has actually just put 2 wind turbines off our coast. And we're going to rely, they're actually increasing their portfolio of both solar power and wind power. So as they increase that portfolio, then when I charge my car, hopefully I'm not relying on coal or oil generated electricity. So I think that it takes individual choices that we all kind of think about, do I want something or do I need something? And pull back on our consumer tendencies. I think it's about governments implementing practices to help us mitigate those carbon emissions. And I think it's really important. And I focus less on that, more on adaptation strategies and dealing with the problems that we have in the research that I'm doing. But there's so much work that all of you could do when you go to college and become engineers and scientists in looking for ways that we can mitigate our carbon out, and also looking for these adaptation strategies that can help us become a resilient society that still is able to enjoy the wonders and the natural beauty of the world that we live in.
So you already mentioned there is a question that you kind of answer with the answer of the previous question, but I'm going to formulate it again just in case you have more to chime in. And this is from Katie Last from England. I'm hoping to study architecture in the future, and I want to specialize in sustainable practices of the subject. What would you say will be the most effective feature you could incorporate into building design to help combat climate change? I know you already mentioned some of them, but I wanted to bring the question back just in case you have other ideas in mind.
Yeah, I mean, I really think that, again, you have to take that holistic approach. And when I think about sustainable building practices, I think it's about where are you building the building and is it an appropriate site? And then how big is the building footprint? And if there is a natural environment there, can you leave most of that natural environment there? Or if you're building on a site that's been previously built on, can you actually rehabilitate the site and bring back into the site more natural environment? And then thinking about what are the types of materials that you're using in the building? What type of impact does their manufacture and transport have on the building, have on the environment, right? So choosing products, choosing methodologies in construction that reduce the impact of the building during construction, but then also in the design, considering energy needs for use of the building. And again, that goes back to kind of lighting and HVAC systems. And then also considering how can residents in the building actually teach other people maybe about their sustainable building and methodologies that are used in their building that they can use at their homes or other places. And then also providing opportunities for the residents or the users of the building to kind of recycle their materials that can be recycled. And then the last piece of it is actually transportation. Can that building be located along a transportation corridor so that I can take a bus from my house to work and I don't have to drive a car? Or can I have bicycle parking and showers in the building so that I can ride a bike to work instead of driving a car or riding a bus? Now I'm getting some exercise, and I'm also able to come to work and even shower, like they put showers in the building so that people can shower and then go to work. So again, I think that if you Google the United States Green Building Council, and actually I'm sure that there's a Great Britain Green Building Council. So if you Google that, you'll actually kind of see that they have sustainable sites, transportation, energy use, materials that are used in the building, the sustainable site practices that you can use for that. So that you find a lot of information about that, and I think you find it really interesting. And then another thing that we're doing here in Hampton Roads, Old Dominion University Engineering is actually partnering with Hampton University, and we have an organization called the Coastal Community Design Collaborative. And this is a really unique opportunity to work with communities. It's a 2-course series. In the first course series, you learn about adaptive design. And in the second course of the series, you actually go into neighborhoods that are having problems with flooding and look at how you might redesign the streets and the landscaping to mitigate the impacts of flooding, and what other natural features could you add to mitigate the flooding. And actually, they did a study in Chesterfield Heights here in Norfolk, Virginia, and the it was a senior project, and the result of the senior project was used by the Commonwealth of Virginia to apply for a housing and urban development grant. And the Commonwealth of Virginia got over $100 million to implement some of these green infrastructure neighborhood practices to mitigate flooding in a historic neighborhood in Norfolk. So looking for opportunities within your a university that you choose to learn about these practices and how you can implement them will really push you forward in your ability to do this in your career. And it's so exciting to help imagine what the future will be under changing climate. And so it's not exciting that climate is changing. I just want to clarify that. I think that, we really need to do everything that we can to mitigate that. But I think there's exciting opportunities for young people to come up with innovative ideas on how to mitigate climate change, but also how to adapt to climate change.
Right. So the next question, well, we're running out of time, but I think we could handle 2 more questions. So Chloe Webb from New York. The question is there a sturdy replacement for wood in houses and furniture?
So wood actually is renewable, right? I mean, and so they actually, as part of sustainable building practices, have certified wood that comes from forests that are sustainably managed, right? So there's opportunities to still use wood, but just get it from, and it's called an FSC, I think it's the Forest Stewardship Council, right? And there's other certifications also, but to get the wood from forests that have been certified to be sustainable. And actually what they're finding is that they're looking at changing the way that we use wood to use it in structures that are more than 2 or 3 stories. Right now, we don't use wood for buildings that are probably greater than 2 or 3 stories, but they're looking at structurally using wood for buildings that are 5 or 6 stories because wood has less of that climate impact than steel or concrete does. So I would, again, refer you to the USGBC LEED website, and I'm sure through there you can find these certified wood products, or you could just search FSC for forest. FSC is the initials, fsc.org, and I'm sure you would be able to get more information there also.
Thank you, Carol. There are 2 more questions from the same person, but this is weird because the location in one he says or she said is from Israel and another from Illinois. So in any case, let me try to combine those 2 questions because the 2 questions are related. Is Karim Samapkolsky, I hope I pronounced the last name correctly. What would you recommend for schools in terms of small improvements to improve its sustainability? But the same thing, the similar question goes to what would you recommend to everyone as individuals to improve sustainability? So what are the recommendations for individuals? What are the recommendations for schools?
So, I mean, I think you kind of have to look at your whole operation and think about it in terms of that, and again, I love the strategies that we use in the USGBC, United States Green Building Council, because it makes us think about how do we get to and from work, right? Can we use public transportation? Can we ride a bike? Can we reduce our carbon footprint doing that? Our diet, can we reduce our carbon footprint just with our diet? Eating a plant-based diet, not eating beef, thinking about those choices is an opportunity to reduce our impact. In terms of travel, airplanes emit a lot of carbon dioxide. So thinking about travel, and I love to travel, I love to go places, but can you do a carbon offset, right? When you think about your travel, thinking about the types of things that you purchase, how they're made, how far they are sent to you, kind of thinking about that supply chain, thinking about our energy use, right? Can you set the thermometer in your house in the summer a few degrees warmer, or in the winter a few degrees cooler, so that you're using less energy? So those are some strategies that we can all look at. And actually, there's carbon footprint calculators online that can help you do an evaluation of what your carbon footprint is. And based on that evaluation, they'll give you some ideas on how you can reduce your carbon footprint. So I think those are good resources for a place to start in terms of thinking about our carbon footprint in everyday life.
You know what? I was gonna take that as a last question, but there is one that is really interesting. Sorry, I'm gonna take one more, and this will be the last. I'm wondering. This is Johanna. I don't know where she's from. I'm wondering what Professor Considine thinks about the fact that 44% of methane emissions come from livestock, and how we can encourage people to stop consuming so much meat. Then do you think, Carl, that it would help us quicker than trying to get people to buy expensive cars like the electric ones and so on and so forth, or buy new buildings, new things? It seems like a simple switch to a plant-based diet would be quicker.
I think we have to approach this from all aspects of our lives. I don't think we can choose one and think that's going to be the solution. I think we have to look at all areas to reduce our carbon footprint. I think diet is certainly one area that is an excellent opportunity for us to reduce our carbon footprint. Having a vegetarian diet is one way to do that. I think for all of these solutions, it all requires us to make choices and change, right? And sometimes that's what's really hard for all of us. Everyday life gets in the way of making choices that have long-term implications for us, either positive or negative sometimes. And so it really does take a conscious effort to make these changes. And I would argue that we need to make them in every aspect of our society, not just one. But I think a plant-based diet is one place to start.
And that's gonna be hard for me, but okay. I'll see. I'll see what I can do. Carol, thank you so much for a great talk. It was really interesting and very engaging. Thank you so much. I'm pretty sure everybody, all the participants also agree with me that that was a great talk. Thank you, and thank you for answering all the questions. Thank you.
Yeah, I want to thank everyone that was here today. I hope you learned something new that you didn't know, and I hope that I've directed you to some resources that might be valuable to you. And I wish you all a very happy and productive summer. So take care. Thank you so much, Orlando. I truly appreciate your help.
No problem. My pleasure. Thank you. Bye, everybody.
Bye, everyone.
Thank you.